7, where we started to investigate compound interest with savings accounts. One thing to keep in mind is with savings accounts, yes, your money does grow over time, but this is also a formula that can be used for loans. So when you take out a loan, for example, $4,500, this formula will tell you how much you would pay on the life of that loan. So that loan also will increase. So when you borrow $4,500 for a car or to go to school, by the time you pay that off, you will pay more than $4,500. But in this case, we are looking at a savings account, earns interest at an annual rate of 3.5% compounded monthly. So just so we know, monthly means that you're getting paid 12 times a year. If the present value
on your phone, because I don't want to do it on the exact same
12 times a year. If the present value is 4,500, what will the future value be in 10 years? So other things about the information we're given, there's our R, there's your T, and then 4,500 is your original present value P, or sometimes it's called the principal. Our formula then is A equals, and we're going to plug everything in, 4,500 To calculate your interest, you're going to take 1 plus, so 1 represents 100%, so you're getting 100% of that $4,500 back, plus your rate divided by the number of payments. So each month you're going to get your interest rate, which is 0.035, divided by 12. So they're going to take that percent, that's always a yearly percent, and divide it by 12 to figure out what percent of that payment you get each month. Then we're going to raise that to the power of t times n. So I'm going to erase that, and then we'll rewrite t times n, with 10 is the number of years, number of payments is 12 because of monthly. Now it becomes a calculator problem. So we'll head into our calculator and head over to calculate that. So we'll take 4,500, and you can open up a set of parentheses, 1 plus, I like to use the fraction button, it's alpha y equals, our rate is 0.035 divided by 12. And then once you do that, get your 12 in there. Let me do that again. So 0.035 over 12. Then you're going to want to arrow out, which I didn't do that first time, to get out of that fraction. Now we're going to close it off. So there's my 1 plus r over n. Then we're going to hit our power button, which is right above divide. And we're going to take 10, number of years, times 12, number of payments per year. So at this point, if you need to, you can always rewind if you're watching the video, or you can pause it to make sure yours looks like this. Now we'll hit enter, and our results, $6,382.55. So 638255, 638255. And you may be wondering, well, what do I round to on these? Well, money is always rounded to the nearest hundredth. So 2 decimal places to represent dimes, and then pennies. On number 57, we are going to use continuous interest. So your account value with continuous interest is going to be your present value times the number E raised to the RT. This is sometimes called the Pert formula. So E is the maximum interest that you could earn if your money was being compounded. You were getting payments infinitely throughout the whole year. So a mathematician named Jakob Bernoulli wanted to figure out if he invested $1 and the bank paid him continuous interest infinitely throughout the whole year, what's the maximum amount of money that he could earn? And he found out that you could earn $2.71, and then it goes 828, and then 1828. And it's a number similar to pi. It's irrational, just keeps on going forever and ever, but the maximum amount of money that you could earn is 2.718, or about $2.72. So that's what we found out. Then we'll use this formula to find this compounded continuously. So A equals, P is 3,400, that's the present value, times E, And then we're going to raise it to the RT. So R 0.04 times the number of years, which is 5. So PE to the RT is also called the Pert formula. So that's the order of those letters that you see arranged in the formula. Heading to our calculator, we'll hit 3,400. Then the E button is right next to the 4. You hit second. 4, right next to the 4, ln. Now have an E raised to a power, and then we're going to hit 0.04 times 5. So there would be our power RT. We hit enter. So if we're earning interest compounded continuously, 4%, after 5 years, our account would be at 4,152 and then 77, because that 9 would raise that up to a 7. So 415277. So let me get that. 4152.77. So there would be our amount of money earned after 5 years. Again, if you're struggling with the calculator, remember you can pause, you can rewind, and then follow those key sequences.